Thanks, James. Hi, everybody. Welcome. Thanks for coming along to my talk. Are you all having a good day so far? Yeah? Hands up who's seen the dinosaur? Yeah. Hands up who's been scared by the dinosaur? Yeah, a few of us, I think. All right, so I'm giving a talk today called Solid as a Rock. Now, I put a question mark on there, so it's actually solid as a rock, because we think of rocks as something that's really solid and something that are permanent. You know, rocks are really strong. And we use that term a lot, like solid as a rock, written in stone, rock steady. They're all terms that mean that something's permanent. That's the way it's always going to be. And so I'm here to shake that up a little bit and hopefully help you to realise how rocks change over time. But we're not talking about lifetimes, we're talking about geological time. And I'll put that into perspective a little bit later. But so rocks being nice and solid, and there's other ways in which we use that term, like the rock. He's very solid, he's very strong, that's why we call him the rock. This is Alcatraz, which is was a prison that was known as the rock, because it was impenetrable, nothing could get in or out. So it was really strong and solid, solid as a rock. But rocks actually change over time, and there's different processes that happens with. So one of them is erosion. So erosion can break rocks apart and move parts of rocks to other places. Both of these you can see here, mountain tops, where the mountain's being moved away. And you see a mountain, you think of it as so permanent, a great big mountain on the landscape. But over time, mountains entirely disappear and go down into the oceans. And then new mountains can get formed from the oceans bending and folding up. So we'll get some more of that later. So that's one of the ways, erosion. Another way is through melting. Did anyone see the volcano going off earlier? Yeah? So that's where we see molten rock. So under the earth where it's really hot, you can get magma, which is molten material under the rock, so when rocks are liquid under the ground, or lava, which is when they're liquid on the surface. So melting is another way that rocks can change form. And another one, this one's a bit trickier to imagine. This one's metamorphism, so a bit like the caterpillar turning into a butterfly. Sometimes rocks can turn into whole other types of rocks. And this is just when they're buried really deep, like under mountains, under lots of pressure and high temperature. And it means the ingredients in the rock, the minerals in the rock, get cooked and they all switch around and turn into different types of minerals and different types of rocks. And so to understand that a bit better, we first need to learn a bit about what minerals are. So we'll talk about the difference between a rock and a mineral. So you can see I've got a whole bunch of things here, and a bunch of them are rocks. So for instance, I've got a rock here and another rock here. This one here, you can see it's all made of the same thing. And this one is a mineral. So minerals are the ingredients that make up your rocks. So I've got a few different minerals here. We have some of these ones. I have quartz, is this mineral here. This one is feldspar, so that one up in the middle there. And this one is a biotite. So each one of those on their own is a mineral: quartz, feldspar and biotite. But if you take them all, mix them all together into one rock, so a rock whose ingredients are quartz, feldspar and biotite, you come up with a granite, which is this type of rock here. So you might have seen rocks like this. Some people have them in their kitchen bench tops. They make a really nice pretty kitchen bench top in granite. And it's got the little black bits, is this mineral, biotite. The white bits are the feldspar and the grey bits are the quartz. And at the end of this talk, you guys can all come up and have a look at the stuff on the table here and you'll be able to see it a bit more closely. So that's the way to think about it, that minerals are the ingredients that make up a rock. A rock is made of minerals. So the other thing we'll need to talk about before we get on to how rocks can change from one type into another is geological time. So I said we're not talking about your lifespan or your grandparents' lifespan or how long ago it was that your great-great-great-grandparents lived. We're talking about geological time. So this is the geological time scale, and it's a representation of the history of the Earth. Up the top we have today, and at the bottom we have 4.6 billion years ago. That's 4,600 million years. So that's a lot of time to try and imagine. So we'll make it a bit simpler first. So we'll take that yellow bar there. We imagine that represents 20 years. That's a bit easier to imagine. You can imagine 20 years. So there we have today, and at the other end we have 20 years ago. So that's 2/3 of my lifetime ago. So that's still a pretty long time, 20 years, but it's a time you can imagine, 20 years. Okay, so let's take that line and let's multiply it by 10. So now that line represents 200 years. All right, so 200 years ago, now we're talking about the olden days. So people with horses and carts and things like that. Maybe your great-great-great-grandparents maybe were alive. But so now we've got a line that's 200 years. Let's multiply that by 10, and we've got 2,000 years. And what was happening 2,000 years ago? We have ancient Egypt and ancient Rome and Cleopatra and Julius Caesar and things like that, all those ancient civilizations. So now we're going back 2,000 years. So we're starting to get some really big amount of time now, 2,000 years. Let's multiply that by 10, 20,000 years ago. What was happening 20,000 years ago? We have the ice ages, we have cavemen, ice ages, mammoths, things like that. So that's what we're talking about 20,000 years ago, people working with stone tools and that sort of thing. So 20,000 years, we can still just sort of keep in mind how long that might be. Well, times by 10 a lot of times since we're talking about 20 years ago. Well, let's times by 10 again. We have 200,000 years ago, and that's actually where we have the earliest evidence of Homo sapiens. So that's humans, our species. So our species first evolved around 200,000 years ago. So we're going quite a way back in time now to get to that point. Let's multiply it by 10 one more time to get 2 million years ago. And that's where you have some of our ancestors. There were Australopithecines and Homo habilis and Homo erectus. So these weren't even actually humans, but they were other ape-like humans that lived back then. So now we've got a line that represents 2 million years, and we've multiplied by 10 a lot of times to get there. So we went 20, and then 200, 2,000, 20,000, 200,000, 2 million years. Now we'll take that 2 million years, so there it is. I'm going to squeeze it into that little sliver there. I'm going to pop it up at the top of the screen there, if you can see it up the top. Now this is still only part of the timescale I showed you earlier. So here we have what we call the Phanerozoic, which is the last 540 million years. So you see that 2 million up the top, with all that human prehistory squeezed into that 2 million years up there. Now I'm just going to need a volunteer for the next bit. Okay, so your hand up there first. Yep, if you'd like to come up here. What's your name?
Sid.
Sid? Okay, Sid. If you'd like to take this end of this string and hold it up nice and high. So you can see the little yellow bit on the end there. Don't know if you can see, it's about 1 centimetre. That is at 2 million years. This piece of string is 23 metres long, and that represents geological time. This part that we're showing on the screen here goes to here. There's 540 million years. We've still got about another 20 metres or so of string on here. So you can see how this period of time that we're looking at, of geological time, has such a long time that the Earth has formed before that. So if you can just keep holding that there for a moment, Sid. Actually, we'll swap ends because I need to press the button on there. If you go over there. Excellent. Now, on this string, where the green part starts here, that's about 66 million years ago. Is there anyone here who knows what happened 66 million years ago? Yep?
Big Bang?
No, the Big Bang. Place there was an explosion. Yep.
Dinosaurs.
Yeah, that's when the dinosaurs went extinct. That's right, the dinosaurs blowed up. That's right. So that's where you have the end of the dinosaurs. Now that's at the end of the green part up there. The start of the dinosaurs was down in the Triassic. So that's here. So you've got the purple, the blue, and that green is old dinosaurs. Compared to that little 2 million years, it's only humans are a tiny fraction of. So you can see dinosaurs were on the Earth for a very long time. Although one interesting thing about that, you often see pictures like this with Tyrannosaurus rex and Stegosaurus together. Tyrannosaurus rex lived up here in the green bit, and Stegosaurus lived down here in the blue bit. They were much further apart in time than that. The Tyrannosaurus was actually closer in time to us than it was to Stegosaurus. So a picture like that is very inaccurate. A picture like that is much more accurate than the one with Stegosaurus and Tyrannosaurus together. All right, we're finished with this. Thanks, Sid. You can sit back down. All right, so going just through this other part of the time scale here, I've pointed out a couple of other events. So in the Devonian was where you have the first fish. We're talking around 400 million years ago. You got some of the first plants during the Silurian, around 440 million years ago. And during the Cambrian, around 540 million years ago, is where you have the first complex life, the first sort of ecosystems with some animals eating other animals and things like that. Before that, you really had very simple life forms and single-celled. So when I say before that, how much time are we talking about? So I'll show you that original timescale that I showed up there. So there's this Phanerozoic we've been talking about, squeezes up into that tiny little bit at the top, and you've got another 8 times that for the length of the actual history of the Earth. So I think that hopefully puts into perspective the huge amount of time we're talking about here for these processes to happen. So the processes I was talking about, like erosion and metamorphism and melting. So that's plenty of time for rocks to become other types of rocks and for the Earth to change and move and different things happen. So it brings us back to this thing of being solid as a rock. And so you can see over that sort of time, rocks really aren't very solid at all. So there's those processes, melting, erosion and metamorphism. And those are each related to the 3 main groups of rocks that we classify rocks as, which is igneous, sedimentary and metamorphic. So we'll start off with the igneous rocks. So igneous rocks are the ones that come from rocks that have melted. We have liquid rock. So when it's under the earth like this, it's called magma. And magma chambers form deep down under the earth, and the magma moves up. And then when the magma comes out the top of the earth, what's that called? A volcano, that's right. So it explodes out, and then you get lava. So the lava on top. Now, when it cools down in that magma chamber underneath the earth, sometimes it never makes it up into a volcano, sometimes it cools underneath the ground. And down there it's really nice and warm, so it can cool really slowly and grow nice big crystals. And that's where granite comes from. So granite, like a new granite bench top, they're crystals that have cooled deep down under the earth, often kilometres down. When it comes out the top, that's when you get rocks like basalt. So basalt is very fine-grained, and I have some here. And so this black rock here, it's very, very fine-grained, and that's because it's come out onto the surface and cooled very quickly up in the air. So there's not much time for the crystals to grow. Another cool thing that can happen with basalt is you can get things like this, where this is what we call a volcanic bomb. So this has come flying out of a volcano, and it was liquid lava that was dripping through the air, and it solidified into a rock as it was falling through the air. And that's why it's this teardrop shape. So that's what you call a volcanic bomb. And then sometimes, like this one, they can carry messages from inside the earth inside. So this is olivine mineral, which has come from, you get that in the mantle, which is really, really deep down, kilometres and kilometres down underneath the Earth's crust. You have the mantle. This is a piece of mantle that's been carried up by this volcano and brought to the surface. So you can get secret messages inside the volcanic rocks. This one over here is also a volcanic rock. This one's called pumice. Now this is the really frothy part of the lava, where the lava's got lots of gas in it and it gets all sorts of bubbles. Now I just want to get someone down the front here to try holding this. You take this, tell people how heavy it is.
Light.
Yeah, it is. It's super light, isn't it? For a great big rock. You want to have a hold? Yeah. There you go. You can pass it around if you like. So rocks can be deceiving sometimes because that looks like a great big rock, but it's very light, because it would have been filled with lots of gas from really frothy lava. So that's how you get igneous rocks. And there's some more pictures of lava as it's cooling. You can see the crust forming on there. And then, so the granite, this is a picture of some granite. And I mentioned how the granite forms deep under the earth. But the place you most often see granite is places like this, where it's on the top of a mountain. So how does it get from deep down under the earth up to the top of a mountain? It's because the earth is always changing. So the surface of the earth is made up of a series of plates, and those plates are moving around and bumping into each other, and they bend and fold, and some get sucked under other ones, some get pushed up into mountains. And so rocks that used to be down really deep can get exhumed and come up really high into big mountains. Then the mountain starts to erode away, and you get the rocks left behind. I've got an example here of some weathering. So the granite where it's up there at the top surface is granite like this. Eventually, where it's exposed to the wind and the rain, it starts to weather, and that's when it starts to look more like this. So I could probably even break this apart if I rub it. because it's been exposed, it's weathering at the surface. And eventually that turns into stuff like this, which is what we call sediment. And that'll get us onto our next type of rocks. But first of all, I'm going to need another volunteer for the next activity. You're on the end there? Start to come up the stairs. Oh, yeah. Okay, so just talk about weathering. You're going to contribute to a little experiment that lots of people have been involved in the past. So we have this pebble here, so you can see how this has been weathered and rounded. So rocks start off being angular when they break. You've got these angles on the edges, and they get rounded by processes like running through a stream and things like that. So what I have here is this bucket has, what have I got in there? There's a clue here. It's managed. Sugar, that's right. So there's sugar cubes. So sugar cubes, this one here, nice square edges. So you take one of these and you pop it in that bucket. Right, and there's lots of other ones in this bucket already. Put the lid on. All right, what I need you to do is shake it. Shake, 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 shake. Shake them all like you're a raging river, breaking up all the rocks. All right. So we'll take the lid off. All right, so I think this is probably the one you put in. It broke a little bit on the corners. But now we've had lots of people do this in the past. So there's other sugar cubes in here that have already been weathered, and they're starting to look a bit more like this one, like pebbles. So you can see some of the different size ones. So some have nice sharp angles, so the more recent ones, and the old ones are starting to get rounded. So that demonstrates that process of that rounding and the weathering of the rocks. And that's how you end up with the sand and sediments in streams and things like that. Thanks, you can sit down. All right, so we've had our granite cool deep down in a magma chamber. It's got thrust up into a mountain. Now that mountain's eroding away. It's turned into sediment. So the question is, what happens to that sediment? So sediment that washes off the mountains ends up in rivers and then gets carried out into the ocean. And so there's a type of rocks called sedimentary rocks. And they're rocks that are formed from those sediments that get laid down in layers, in rivers, in lakes, and in oceans. And so they come flowing off the mountains into the rivers. You can see the sediment there. And eventually they form things like this. So there's a bit of the Grand Canyon here. And you can see the layers in there. And that's from where the sediments have been laid down in layers under the ocean. As new sediments come in, new mountains start eroding, and they lay new layers into the sediments. And so here, again, it's not under the ocean anymore, is it? This one's now out in the desert. So once upon a time it was deep under the ocean, it's been lifted up, and now these sedimentary rocks are eroding away as well. And so all those gaps, that's been laid somewhere else as sedimentary rocks. So you can see igneous rocks can turn into sedimentary rocks once they get eroded and redeposited. So deposited as sediments in this case. And so that just leaves us with our last type of rock to talk about, which is the metamorphic rocks. So we've had the igneous rocks that cooled from lava. They get broken up and distributed through rivers and laid down in the ocean as sediments. Then I was talking about how there's the different plates on the earth all moving around and banging into each other. When they hit each other, it forms mountains. And that's what you can see here, this picture. These would have been flat lines that have all been crushed up together. And you can see in this mountain here, you can see all those curves there would have once been sediments laid down flat under the water that have been pushed up into a big curve, and then that's created those mountains. And metamorphic rocks form underneath those mountains. They only form where the pressure's really high and the temperature's really high. And then the ingredients in the rock, so the minerals that make up the rock, they're only certain types of minerals like to form at certain types of pressures and temperatures. So when you change the pressure and the temperature, some minerals don't like to be there anymore, and they turn into other types of minerals. And so this is a metamorphic rock, where you've got these big crystals that have grown amongst the other ones. And so the minerals making up this rock have changed to form this metamorphic one. And so here, that's formed into a mountain. What do you think is going to happen over time to that one? Yep. It's going to erode away. That's exactly right. And so that's really the main thing I wanted to highlight, is that while we see the landscape as being so permanent, that mountain is that mountain, But over geological time, that really huge expanse of time there is, the mountains are constantly just dissolving away and new mountains are forming and then dissolving away. New rocks are being laid down. Oceans get filled in eventually and forming all different types of rocks, and new things melt and new volcanoes erupt in different places. So the Earth is very dynamic and it's always changing over that long period of time. So that's it. Thank you very much.